So let's get started on looking at the review of the Module 3 test, which is coming up really soon. First thing that we're going to do is we're going to find the domain, range, axes of symmetry, vertex, the y-intercepts, and the roots of this equation. So when we look at this one in particular, we can see that y equals x squared plus 6x plus 8. And so a couple of things that we can do, we can immediately go right to the box method and kind of see if we can factor it. Always some things to check for. Check to see if you can factor it right away. And what I mean by right away, if you have a perfect square in front, of course, 1 times 1 is 1. So there is a perfect square there, but you can't figure out a perfect square for 8. So I wouldn't even attempt that. There's other ways that you can do it. You can complete the square. You can do some other stuff. You always want to kind of look at that and say, okay, what is it that I need to do? Now, notice it's asking me for the axes of symmetry. It is asking for the roots, so I am going to need to factor it at some point. But I can find some things without even having to do the box method. So remember that what we do is we multiply the first coefficient times the last one. So that's 1 times 8, which is equal to 8. We're then going to split that up. So we're going to look at all factors. Notice because this is plus, both sides are the same, both signs are the same. This plus tells me both are positive, so I have positive and positive. We look at all the multiples of 8, 1 and 8. Those do not add up to 9, 2 and 4. Notice I always put the smaller number on the left, larger number on the right. These two add up to 6. Because there's a 1 in front, I actually don't have to do the box method. I can actually factor this right away. It becomes just x plus 2 times x plus 4. So I've already found my roots. So for the roots, I know that x equals -2 and -4. So I know that we have two roots that we have here. So it's going to cross the axes. It's, of course, a parabola because that x squared, but it's going to cross the axes twice. And so now I've got the roots taken care of. So that one's done. I can take care of the y-intercept just by looking at the constant here. That y-intercept is going to be 8. That one takes care of that one. The vertex now I have to go through and figure out. The vertex and axes of symmetry I can find pretty quickly. I know that x equals minus b over 2a. Of course, b would be 6. A would be 1. So that would be -3. That makes sense because it has to be between these two numbers, halfway in between those two numbers. And so that would be my axes of symmetry. So x equals -3 would be my axes of symmetry. That takes care of that one. My vertex is located at -3, so I would have -3 here, and then I have to figure out what the y value is. That means I'm going to have to plug it in. -3 squared is 9. Minus 6 times 3, which would be 18 because it's a -3 plus 8. So that's 17 minus 8, which is -1. Took care of my vertex. And now I just have to figure out the domain and range. Well, this is pretty straightforward. The domain, if it's a parabola, in this particular case, it's going up because it's positive. So the domain would be all real numbers. So I can probably write that down here. Domain is all real numbers, and the range, which is a y value, since it is going up, you'll notice that the lowest point, so the lowest point is going to be -1, which is the vertex. So that means that y has to be greater than or equal to -1. Okay, and that takes care of all those answers really fast. Notice how quickly, if you can get through all this stuff, you've got all of the material here, and I didn't even have to do the box method or anything else. Okay, find the average rate of change of these two different things. First one between -4 and +4, the second one between -4 and +2. So the first thing I have to do is I have to find f of -4, which means I'm plugging in. So -2 times -4 squared, that would be 16, minus 32, because that's 8 times -4, plus 7, that is -32, minus 32 plus 7, which is -64 plus 7. Next, -64 plus 7 is -57. Okay, so that's the first y value, then I have f of 4. That is negative times 16. In that particular case, I have plus 4 times 8, which is 32, plus 7. So negative 16 plus 32. In this particular case, I have 16 plus 7, which is 23. And then to find the rate of change, remember it's y2 minus y1. So we're going to use this as 0.2. So wherever I plugged in the 4, I can kind of take a look at that one in particular. So I have 23 minus a negative 57, because there are my two y values, all over. And then I do 4 minus a negative 4. So that would be 23 plus 57. So that looks like it would be 90 all over 8. So 2 goes into both of those numbers. So that would be 45 over 4. Okay, that would be my first one. On my second one, all I have to do is look at the 2 points. There's 1 point. There's my other point. I have to pick a 0.2. So I'm going to pick this one as 0.2. This one is 0.1. And so in this particular case, I have negative 3 minus a negative 27 all over 2 minus a negative 4. So that'd be negative 3, in this case, plus 27. So that would be positive 24. 2 plus 4 is 6. And so that rate of change would be 4. Okay, and that's what we have for looking at the rate of changes. Now we have to find the zeros. So this is actually really simple. So if we have a graph and we have to figure out the zeros, remember the zeros, roots, solutions, or x-intercepts all are where they cross the x-axis. So I have one at negative 2. I have one at 0. I have one at 3. And I have one at 6. Okay, and if you want to write out the points, you can do that too. That would be negative 2, 0, 0, 0, 3, 0, and 6, 0. Okay, and then now we'll go to the next video for the other problems.